Hello friends, welcome back. Today is another lesson here in probability. So our Springboard lesson today is lesson 20-3, estimating probabilities. Our learning targets for today are going to be interpreting probability as a fraction of the number of times that an outcome occurs when a probability experiment is repeated many times. Also, we're going to be estimating probabilities of outcomes in a probability experiment. So again, I'm keeping a probability experiment as part of our academic vocabulary. Remember, we're going to be looking at things like dice rolls, flipping coins, spinning spinners, pulling things out of bags, etc. Remember, the word outcome is the result of an experiment or a trial. And I didn't put it on there, but remember, estimating means to have like a guess. So we're guessing based on information that we already have or creating kind of a prediction that we talked about before. And again, if we want to connect it to science, we could talk about it as a hypothesis, which is an educated guess. All right, let's go ahead and work on our first example here. Yes, this is a hand-drawn spinner of mine. Thank you. I know you're appreciating my hard work here. But the first question here that I have is, we have our crazy spinner. Just by looking at my crazy spinner, what could you tell me about the probability of getting a 1 if I actually had you spin it and see where it would land? So what are your thoughts on here? Well, when I just kind of look at it myself, and if I'm thinking out loud, I kind of made this section for number 1 super big. So, I mean, yes, it's really goofy, and I cannot give you a probable answer of what percentage of the time I'm going to land on number 1, but it is a pretty hefty size in comparison to the 2 section and the 3 section. So if I had to explain myself, I would say it's probably really hard to tell the exact probability of it. The spinner doesn't have straight boundaries, so I didn't cut it equally in any pieces. I didn't cut it into fourths or eighths or sixteenths, so the chances of it to give you an exact number are not possible. So again, it's hard to work out the probability of getting 1, 2, or 3. I am more than likely going to land on 1 rather than 2 or 3 because the region on the spinner for number 1 covers more area than it does for 2 or 3. So if you had to guess, what is the probability of getting a 1? Is it closer to 0? 0.25, 0.50, 0.75, or 1.0. Remember, this goes back to that probability chart that I talked about in lesson 20-2. So these can be converted into percentages. So the chances of getting 1, 2, or 3. So we're focused on 1 right now. So are the chances going to be about 25% of the time, 50% of the time, 75%, or 100%? Well, if you kind of look at it and what I said, I did take up a pretty large chunk of the spinner. So I would say that it's probably closer to 50% because it looks like about half of the spinner is covering section 1. So again, that was an educated guess. Are we 100% right? Is it truly 50%? We don't know. It could be 37, it could be 42, but again, we are estimating. So we are making guesses based on what we know and what we see. So let's go ahead and move on to our next question. So here are some results from my crazy spinner. So I spun my crazy spinner 12 times, and here are the results. So on my first spin, I got a 1. On my second spin, I got a 2. On my third spin, I got a 1. Fourth spin, 3, so forth and so on. I'm sure you can read that without me having to read the whole section. So as I see here, I have a total of 12 spins. Out of those 12 spins, how many times did I get 3? Well, if I count, I got it once, twice, 3 times. So that resulted in getting 3 times. So if I asked you, now we have probable data. We have data, we collected it, now we can actually calculate a percentage and a possibility of an event happening here. So what fraction of the spins resulted in 3? So I have a 3 out of 12 result here. So if I do this, 3 out of 12 simplifies to 1/4. So 0.25 or 25%. So the chances of me during this actual probability experiment was a 25%. So the chances of me getting a 3 was rather unlikely. So again, even though it was a crazy spinner, we were still able to produce some sort of data and an estimate based off of using the spinner and using what we know. So yes, if I was teaching science, I would say this is a pretty solid hypothesis, but again, we used data and what we knew to help us create these estimates. All right, let's go ahead. That was 20-3. It was pretty easy, nothing too crazy. Now don't forget to hop on into Google Classroom and complete the assignments. If you want, you can take a pause right now, finish 20-3, and then come in, watch the second half of this video. All right, 20-4 is making decisions. Our learning target here for making decisions are to make decisions based on probabilities. So again, now we're taking what we know based off of us calculating the probabilities and using it to make decisions. We're going to expect variation in results from chance processes. So again, there might be times when things are pretty the same all the time, but then there's other times where you might get one number more than what the actual probability was calculated. And then we're going to go ahead and write about the chance process and justify conclusions based on probability experiments. So long story short, we're going to explain how and why we got our results based on what we knew. Again, look in here, keeping probability experiment on the table. Remember, that is flipping a coin, spinning a spinner, rolling dice, anything like that where we're trying to look to see what are the chances of something happening. And again, predictions, what someone thinks will happen. But we're again using data from our experiments to make those predictions. All right, let's go ahead and hop in. So here I have 4 different spinners. They are cut into different ways. Some are more segmented than others, but let's use what we see in these pictures to create our possibilities and our predictions. Order the 4 spinners, starting with the one that has the greatest probability of spinning a 1 and ending with the one that has the least probability of spinning a 1. So just by looking at them, I can see right now that this one right here, that's half of the spinner. So I basically have a 50-50 chance here of getting 1. This one's nice, even cut into 4 pieces. And I have here, remember I talked about that also in the video from yesterday. These are cut into quarters, so there's a 25% chance here. All right, here's one of these quote unquote crazy spinners where 2 is cut nicely here in half. And then we have 1 and 3 kind of sharing the box. Could it be a quarter? Could it be less than a quarter? We don't know. My guess here would probably be it's less than a quarter, because if I take my pen, and actually cut it into quarters, this is like a quarter of a quarter. So it's really like saying it's an eighth. Okay, so that one is there. And then we're looking here at this section. It's kind of bigger than the other ones were. So this one's bigger for this one, from this one for sure, but is this space bigger than this space? Again, this is a square, this is a triangle. Could it be covering the same surface area? We don't know. So my best guesses here, I would say definitely spinner D. Whoops, spinner D is the one with the greatest probability. And spinner C is the one with the least probability. So now I know, earlier I said this one's a 25% chance. So I'm going to take it and I'm going to cut it into fourths and see what I can get from here. Okay, well then this is also 2 and this is 2, so this is 1 and this is 1, so this is also 2. Did that really help me too much? I don't know. Let's see if we cut it into eighths. Will that make it any better? One, 2, 3, 4, 5, 6, 7, 8. Okay, so this is a 2, and 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 this is 1. and this is 1. So we have 2 out of 8, which would be, when I simplify, it's 1/4. Oh snap, that's also the same thing as 25%. So A and B actually have the same probability. So let's go ahead and say A and B, mostly because they are tied for the same amount of space. So again, you can manipulate these spinners any which way you want, as long as you get the data that you need. No one said that you couldn't draw anything different or make it happen. I could cut this guy now into 8 pieces too, and I would still see that I have 4 out of 8, which is 50%, which you can obviously see visually that that is half of the spinner. All right, we're going to continue with these same spinners in our next set of questions. So I am going to erase this just to kind of clean things up because as you can tell, I'm kind of a hot mess here and I was just doodling to make my life a little easier. All right, let's go ahead and go on to our next set of questions. It says, suppose you spin spinner C 20 times and spin spinner D 20 times. Would it surprise you if you got more 1s with spinner C than spinner D? So the question we need to answer and explain is, would it surprise you if I got more 1s with spinner C than D? So let's take a look at spinner C and D. Would it surprise me if spinner 1 gave me more 1s than spinner D? Well, let's take a look here. We figured out that this was only like 1/8 of this spinner. And this is 50%, and this is only 1/8, and I believe 1/8 is 12.5%. So would that be surprising and shocking to you? Heck yeah, it would be surprising. It would surprise me because I expect to get a lot more 1s on spinner D, which we said was already 50%, and spinner C is only 1/8 of it, which is what I told you before, about 12.5%. So again, you're looking at the spinners, you're comparing, you're taking the information that you know or the information that you created, kind of like I did with cutting my spinners into pieces so I could successfully figure out those probabilities. So let's take a look at our next question. Our next question says, suppose you spin spinner A 20 times and spinner B 20 times. Would it surprise you if you got more 1s with spinner A than spinner B? Explain your reasoning. Let's go back and take a look at spinner A and B. And remember what we figured out. They are both 25% of the spinner. So number 1 takes up 25% in spinner A, and number 1 takes up 25% of spinner B. So would it be surprising if you got more 1s on A than B? Honestly, I'm not going to be surprised there. Why would it surprise me? Spinners A and B should spin 1 about 25% of the time. After 20 spins, there should be about the same number of 1s for both spinners, and either one could be the one that leads. So that doesn't necessarily mean when we actually do an experiment that we're always going to get 1 25% of the time. But probability and chance is telling us we should. So a lot of people make their guesses based on that. I believe meteorologists also do a lot of that. They look at data and they look to see what happened, and they base what they predict to us off of information like that. All right, let's keep going. Now I have another new spinner. This is spinner E. Yes, I know it looked very similar to spinner B, but we're going to go a little bit forward with different content here. So now I have some actual data. Now I have data from spinning. We did it 3 different times, and we're going to use that data to make some predictions based off of what we saw. Only one of the following sequences resulted from actually spinning spinner 14 20 times. Which sequence do you think it was? So let's take a look here at sequence 1. So this is, again, some quote-unquote data that was collected. Let's pretend someone was trying to trick us with this information. Now we have to figure out which is the one that would actually be the most realistic. So let's pretend we're spinning here, and I spin a 1, then I spin a 2, then I spin a 3, then I spin a 4, then I spin a 1, and then I spin a 2, and then I spin a 3, and then I spin a 4, and then I spin a 1. That already sounds totally bogus. If you're lucky enough to spin 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4 multiple times, you must be a wizard or something. I don't know. You need to get your letter to Hogwarts or whatever. But seriously, that's totally not possible. So let's take a look at sequence 2. We have 2, 3, 1, 3, 1, 1, 3, 2, 2, 3, 1, 1, 3, 3, 3, 2, 3, 1, 3, 3. I thought we were going up to 4. I'm confused. Because according to probability and chance, once again, each one of these has a 25% chance of happening, and there is no 4 in this sequence whatsoever. Is it possible that we can never get a 4? Absolutely. But there is an equal chance of getting 4 than there is to get a 3 or a 2 or a 1. So let's take a look at this last sequence here. We have 1, 1, 1, 3, 2, 4, 3, 4, 4, 3, 3, 2, 4, 2, 1, 4, 3, 1, 4, 3. That makes a little more sense. We got all of our numbers in there. If we were to order it up and kind of take the data and calculate it to see what it was, I would say that that's probably the most realistic sequence we have out of those 3. So I would definitely say that is the most realistic and the one that would actually happen here. So it says for the other 2 choices you did not select, explain why you ruled out that choice. Well, I'm kind of an overachiever and I already explained myself a little bit. So let's go ahead and see how I would formally write that. I would say sequence 1 has the same number of 1s, 2s, and 3s and 4s, but they go in the exact order, which probably wouldn't happen when the spinner is spun. I already told you that. That's like some magic. And then sequence 2 doesn't have any 4s, and you would expect that you would get a 4 at least 25% of the time. So again, you're taking the sequences and making them be realistic, like which one of these actually makes sense. Okay, and I have one last slide here for you, and I'm done. I think this video is a little shorter than yesterday's was. And let's go ahead and take a look at the spinner. The spinner says, what are the following probabilities for spinning the spinner below? So you know me here. We kind of talked about this in the last video as well. This isn't even, and I'm kind of a picky person, and I like my sections to be equal. And that's just kind of a thing that makes fractions a lot easier for me when everything has that same common denominator. I know that everything's equal, so it's a lot easier to work with. So I'm going to go ahead right now and I'm going to take my pen and I'm going to cut it into eighths because that seems like the most realistic thing I can do here. So taking my pen, cutting it into eighths. 1, 2, 3, 4, 5, 6, 7, 8. Perfect. All right, so I got my eighths, and now I'm going to just kind of put the numbers in the section. So this is a 1, that's a 1, this is a 1, and this is a 1. Okay, grab another pen. This is a 4, and this is a 4, and then we have 2 and 3. So now I have cut all my pieces. Now I have a denominator here of 8 for everything. So my chances here are how many of the sections here are 1. So that's my first one right here. So that's saying the probability of getting a 1. So I have 1, 2, 3, 4, 1. So that's a 4 out of 8 chance, which if you simplify that, that's 1/2. So we have a 50% chance of getting a 1. All right. So let's go ahead and change colors because I feel like it. What is the probability of getting a 2? So out of the 8 sections, again, that I have, the probability there of getting a 2 is only 1. So that's 1 out of 8, which when I divided that already in my calculator, I got 0.125 or 12.5%. Okay, I'm going to keep going. My pen. Denominator's 8. Remember what I said? I did that on purpose so everything is nice and equal and I don't have to worry about anything at this point. All right, my probability of getting a 3. Well, there's only one 3, so I'm putting a 1. And that's also the same thing, which is 12.5%. All right, and then my last one here. My last one here is 4. What are my chances of, my probability of getting a 4? I'm sorry, I'm used to saying chance here. So once again, there's 8 sections and there are 2 out of the 8, Well, you can simplify that. Divide both top and bottom by 2. Here I divided top and bottom by 4. Sorry. And that gave me 1/4, which we know 1 out of 4 is 0.25 or 25%. And those are the probabilities. Now, if we were going to go back and talk about likelihood and unlikelihood, we can say that this one is as likely as not. This one is probably as likely as not means the same thing. It means 50-50. It's as likely to happen as it is not as likely to not happen. This one would be unlikely. So would this one. And this one would be unlikely too. I mean, it has a bigger chance than getting a 2 or a 3, but it's still pretty unlikely because when you look at it on the scale, it falls in between there. All right, well, that is it for me. I truly hope that these videos are helping you out and you are able to finish your assignments. Our next lessons will be taught by Miss Angela, so I hope that you understand what's happening over there on her end. And if you do have any questions about anything, please make sure you're going to your math teachers. I know Miss Cernak, me, and Miss Angela are here for you whenever you need anything. Make sure you're, once again, checking in with your teachers every single day because of the complete and incomplete grades that we are giving now. We're almost to summer break. Keep working hard, and I hope you guys have a great rest of your day. Bye.